everyone. America leads the way in space exploration. As Courtney noted, a NASA-funded telescope, the Atlas Survey Telescope in Chile, first reported observations of the comet on July 1st, 2025 to the Minor Planet Center. And NASA has been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural, solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star, like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet, and all evidence points to it being a comet.
NASA's message was simple enough to fit into a headline. 3I Atlas is no threat to Earth. But the message didn't match the actions that followed. While the public was reassured, the International Asteroid Warning Network quietly shifted into its largest tracking campaign in years. Observations accelerated, telescopes were reassigned, space-based assets were repointed. What began as a routine interstellar visitor suddenly demanded round-the-clock monitoring, all while NASA maintained a calm, almost dismissive tone. That tension between what was said and what was done is where the real scrutiny begins. The whistleblower post that ricocheted across social media only amplified the unease. The message was blunt. 3I Atlas wasn't behaving like a normal comet. It wasn't point-like, its brightness peak was inconsistent, and its shape kept breaking orbital calculations. The wording had the breathlessness of internet alarm, but the concerns themselves weren't invented. Even experienced astronomers following the object noticed that it didn't settle into a predictable profile. Instead, it fluctuated, shifting its brightness in ways that defied the clean curves that objects governed by sublimation usually follow. The claim that its odd shape kept breaking orbital models sounded sensational until those same instabilities appeared in published astrometric solutions that required repeated correction. Something in the visitor's behavior wasn't lining up. NASA's insistence that there was no threat only sharpened the contrast. If the object truly posed no concern, why fast-track an IAWN campaign that typically mobilizes only for potential planetary defense scenarios? Why push for more observatories, more observation time, more frequent updates? Agencies rarely pour resources into a skyrock unless they believe the margin of error is worth shrinking. The sudden urgency, combined with the timing of 3I Atlas's approach toward Jupiter, made the secrecy feel less like routine caution and more like a scramble to understand something unexpected. Bridging the gap between the whistleblower's ominous tone and the scientific reality was astrophysicist Avi Loeb, who began cataloging a list of anomalies associated with 3I Atlas. Loeb's involvement is always polarizing. His willingness to entertain unconventional explanations has made him one of the most public voices in interstellar object research, but also one of the most controversial. Still, his habit of confronting the data on its own terms meant that his analysis resonated far beyond the fringe. He pointed out that 3I Atlas was not fitting neatly into the categories astronomers rely on. The more observations accumulated, the more the object seemed to resist classification. One of the earliest red flags involved the object's trajectory. Interstellar objects are rare, and each one arrives with a unique path through the solar system. But 3I Atlas exhibited non-gravitational acceleration, small deviations from the orbit predicted by gravity alone. This behavior is not unprecedented. Comets often exhibit it when jets of gas push them slightly off course. Yet in this case, the magnitude and pattern of the acceleration weren't matching the expected effects of outgassing. Loeb noted that the distribution of sunlight on the object, the thermal response, and the resulting force should produce a consistent push. Instead, the deviations from prediction were irregular enough that orbital solutions required constant refinement. Models broke, got patched, then broke again as new data arrived. It was as though the object were subtly maneuvering or being nudged by something other than the typical cometary processes.
The shape and brightness profile deepened the puzzle.
comets usually blur into a diffuse coma with a clear brightness peak at or near the center, the nucleus where sunlight vaporizes ice. But 3I Atlas's peak wandered. In some frames, it appeared offset. In others, it looked smeared, the nucleus uncertain or possibly elongated. Amateur astronomers captured images that showed a faint greenish glow typical of carbon-rich cometary material. But the glow lacked the symmetry expected from a simple icy body venting in the sunlight. If the object was tumbling, the light curve should have revealed periodic changes. Instead, the changes were inconsistent, suggesting either an irregularly shaped nucleus or a distribution of reflective material that didn't rotate in a predictable way. Researchers attempted to fit the data to different shapes, elongated, lumpy, multi-component, yet none of the equations remained stable for long. Then came the sideways lines, a term that spread through online astronomy communities after observers detected narrow streaks near the comet that didn't match star motion or satellite interference. Loeb publicly suggested that these streaks might represent smaller objects being released from 3I Atlas, mini-fragments or potential satellites. The idea sounded dramatic, but fragmentation is not uncommon for comets under thermal stress. The question was whether these features aligned with natural fragmentation or hinted at something less expected. Some astronomers dismissed the streaks as processing artifacts, while others argued that they were real but likely benign. Still, the timing of the observations and their alignment with the comet raised enough eyebrows that they became part of the growing anomaly list. Compounding the mystery was the delay in releasing high-resolution, high-rise images. Loeb publicly criticized NASA for withholding data captured weeks earlier, arguing that timely release was essential for understanding the object's physical characteristics. High-rise, normally used for Mars imaging, had taken advantage of a brief viewing window to photograph 3I Atlas when its geometry allowed for unusually sharp detail. But those images never reached the public on schedule. Whether due to bureaucratic backlog, shutdown-related delays, or deliberate caution, the absence of critical data during the most important period of observation created fertile ground for speculation. The lack of transparency wasn't evidence of anything extraordinary, but it was enough to keep the narrative simmering. Each of these anomalies, trajectory deviations, shifting brightness, structural uncertainty, and missing imagery, could be explained individually through natural processes. Comets fragment under stress. They tumble unpredictably when their shapes are irregular. Their jets can fire asymmetrically, kicking them slightly off course. Observational noise and early measurements can bend models in misleading directions. Data releases can stall for entirely mundane reasons, especially when multiple agencies are involved. Standing alone, none of these factors would raise more than an eyebrow. Yet the issue wasn't any single deviation, it was the whole picture, the cumulative weight of features that didn't line up the way they should have. Instead of converging toward a stable model as more data came in, the anomalies spread further apart. They didn't collapse into a unified explanation, they sprawled, pointing in multiple directions at once, like a jigsaw puzzle with pieces from different boxes. The more researchers tried to force the pieces together, the more the gaps became visible. Even conservative astronomers, professionals who normally emphasize caution and dismiss early irregularities as artifacts, began acknowledging that 3I Atlas was not behaving like either of the two previous interstellar visitors, Oumuamua and 2I Borisov. It belonged to the same category by definition, but it wasn't a recognizable sibling. It lacked the clean cometary profile of Borisov. It lacked the predictable reflective signature that made Oumuamua so perplexing yet analyzable. Instead, 3I Atlas drifted in a gray space between the familiar and the unprecedented, refusing to settle into the neat astrophysical templates that scientists rely on. Where other objects grew clearer under scrutiny, this one only grew more ambiguous. The buildup of uncertainty only grew as 3I Atlas approached its close interaction with Jupiter. Planetary scientists tracked the object's trajectory as it prepared to skim past the edge of the giant planet's influence. Such flybys are rare opportunities. Jupiter's gravity has the power to deflect, accelerate, or even capture objects that pass within certain distances, but it also serves as a test. If the object's behavior changed in ways inconsistent with the modeled gravitational interaction, the anomalies would grow harder to dismiss. If it behaved exactly as predicted, many of the more speculative concerns would fade. Astronomers waited, some with professional curiosity, others with a sense of dread, for the data that would emerge after the encounter. In the broader public imagination, uncertainty is fuel. The more the object resisted classification, the more people wondered whether the official reassurances should be trusted. Yet the scientific community remained cautiously anchored. Questions persisted, but catastrophic speculation was premature. The reality sat somewhere in the middle. The object was strange, stranger than most comets, but strangeness is not evidence of intent or threat. It was simply evidence that nature still had surprises waiting at the edge of interstellar space. But the patterns were impossible to ignore. A sudden expansion in monitoring, a list of anomalies growing longer with every observation cycle, a mismatch between public messaging and scientific behavior. A catalog of unanswered questions from one of the most visible astrophysicists in the world. A delay in releasing critical imagery at a moment when clarity mattered most. Each thread, examined alone, was manageable. Together, they formed a tension running through the scientific and observational community.
On March 16, 2026, it will come close to Jupiter, within 54 million kilometers from Jupiter, and there is a spacecraft orbiting Jupiter called Juno that we hope that NASA will use to learn more about it.
As the world waits for the post-Jupiter data and whatever new images or measurements emerge, the mystery of 3I Atlas sits at the intersection of science and speculation. It could be nothing more than a particularly unruly interstellar iceberg, shedding material and venting unpredictably as it crosses its first star system in millions of years. Or it could be something that challenges current models in ways far beyond what scientists anticipated. Interstellar objects are more than visitors. They are tests. Each one pushes the limits of what astronomers believe they understand about the cosmos. The lingering question is simple and impossible to answer until more data arrives. Is 3I Atlas an ordinary object disguised in extraordinary behavior, or is it the first true outlier, a messenger from beyond that refuses to follow the rules? The answer may come soon, or it may never fully resolve. But for now, the object continues its silent passage, carrying with it a mystery that neither whistleblowers nor scientists can fully unravel. A reminder that the universe still holds stories we're only beginning to learn how to read.